We can welcome our next guest, Paul Merino, Managing Director at Honext Material. And he will talk about a full sustainable business model. So I'm very, very curious because I'm studying exactly this. Welcome, welcome, Paul. And please, it's your time.
Perfect, thanks. Thanks a lot for inviting me. And yes, so let me share a presentation. I'll explain with you what we understand as a fully sustainable business model. So we at Honext, what we are specialized is on how to, let's say, we were born based on a process that upcycles waste fiber into construction materials. So we developed a process back in university to transform waste cellulose fibers into boards. Having said that, and as we will see in the presentation, what Esther said in her presentation was totally right. I mean, sustainability can be understood as the raw materials you use, as the recipe you use to formulate the final product, the recyclability of the final product, and that's what many companies look at. But in our case, it is an industrial process. We made one step further and was to consider how can we scale it up from an industrial point of view, having a positive environmental impact. And that's a bit, I mean, I'll go through all of them, and at the end, I'll show you what's our proposal to achieve that. To start with, and going to the raw materials, what we make fiberboards, very similar to the wood-based fiberboards, but the different point is that we are using 100% waste as raw material. Actually, our main raw material is what is called the paper mill primary sludge. And this is the fraction of fibers that paper mills that use post-consumer paper as raw material can no longer use. It's fiber that has undergone too many recycling cycles and that they have to throw away. That's what we take in as raw material. And we also take a part of post-consumer cardboard that allows us to compensate the fluctuations on the industrial waste that we receive. So you have a number in mind. Around Europe, we generate roughly 8 million tons of sludge every year. And the more paper we recycle, the more sludge we generate, because paper recycling processes are very mechanically stressful, and that ends up breaking down the fiber to a size that is no longer useful to manufacture paper. And another fact that you could keep in mind is that normally for every ton of paper produced, we make between 50 to 100 kilos of sludge. So we take this sludge, we mix it with a fraction of cardboard, and then going into the recipe, what we have done is develop a recipe based on a biotechnological process that allows us to take this fiber and shape it as a board without using any kind of resin. I do not know how familiar you are with resins, but resins, they are substances that give great mechanical properties to the product, but have two very, very negative impacts on its life cycle. To start with is that they have emissions of volatile products that have proven to be cancerogen to human beings. And secondly, due to the resins, many products cannot be recycled. And therefore, let's say resins make great products for one life, but that also are slightly contaminant to human beings. So instead of that, we moved away, and what we look is at how can we work the fiber with enzymes to improve the natural ability of cellulose fiber to link among them. I'm pretty sure all of us have at some point taken a piece of paper, threw water on it, shaped it, and once it got dry, it had some mechanical properties. It would not just fade away. It kept the shape. And that's because fibers, when they dry, when you hydrate and afterwards you dry, then they generate hydrogen bonds. So what we looked in here is how many hydrogen bonds we need to substitute the resins, and then how can we generate them? And that was an enzymatic process that we developed. And this way we ensure that the product has no added emissions of volatile compounds, but also, and most importantly, that it can be 100% recycled back into the same product. So it's not just that we upcycle the waste that otherwise would go either to landfills or incineration, but also that the product that we make is 100% recyclable and without emissions. And from an industrial point of view, we also thought, okay, so we have the process, we've developed it in a lab. where are we to set up our factory now? We decided to build it in a landfill because in there, all the energy that we are using is decarbonized. We capture the biogas, the biomethane that is released from the landfill, and that's what we use both for as a thermal power as well as electricity. And the water that we use in the process is the leachates. Everything that goes to the landfill that is liquid, we clean it, and that's the water that comes into our process. And when we have to clean a fraction of it, we just send it back to our wastewater treatment station and clean it, and they feed it back to us. So we have all our utilities come from waste, and we don't have any wastewater on the process. This allows us to be, to my knowledge, the most circular fiberboard in the market. We are actually Cradle to Cradle Silver certified. We are aiming for gold in the next renewal. It's pretty challenging, especially being made of industrial waste, because Cradle to Cradle, I don't know how familiar you are with it, but it's a very strict certification, and it goes down to all your suppliers. And sometimes, or at least the first time, what it happened to us was that the waste producer didn't have enough information of their waste at the level and that Cradle to Cradle demanded. We expect that they do now, and so that's our idea, is to become Cradle to Cradle Gold. And it's all, well, we have the Green Building Council data sheet that also explains the credits that we bring to construction projects in the shape of LEED or BREEAM certifications. But again, this is from a sustainable point of view.
Hi,
Hello?
No.
Okay, yes, so someone was speaking. So from a technical point of view, and it is let's say ours is a technical material. It's a material to be used in construction, and this is, as you all know, a highly regulated industry. So we have all our technical properties validated by third parties. Over the last 3 years, we've been developing with the Construction Institutes of Europe the European standard to cover our material, and this way, we really make it is the way that we follow to entry in a very regulated industry. And this is the material. So out of the waste, that's what we make. It's as simple as fiberboard panels of 122 by 244 meters to be used on the interior built environment. To start with, as panels for decorative uses, mainly in walls and ceilings, but also for acoustic applications. To me, what is the most important on this picture is that we don't want to be a design product, because in order to have impact, we need to reach large scale, which will mean that we are upcycling huge amounts of waste, but we are also putting in the construction market a lot of recyclable material. And to do that, our innovation is on the product, on the core of a material that is afterwards transformed to several products, being it walls, acoustic ceilings, furniture, and so on. To do that, the key is that this core has to have the same processing abilities as the current market products, be it an MDF, a particle board, a drywall, and so on. And this is how we developed our product, and it's what we have achieved. And actually in this picture, you can see some of the examples where it's been painted following normal, either manual or automatic painting lines. It can be CNC'd with as many holes as you want, or with lines. It can be cut down to the size that you need. So it is actually a material that can be applied in several applications using the same processes as the current materials. And that's why we believe we can have a huge impact. Here you can see some of the first applications that we've had as cladding material, in some cases with decorative purposes, as an acoustic ceilings. It was used both as a continuous ceiling as well as as acoustic tiles. We've been used in shop fitting as shelves. So again, it's a material that can be transformed to practically anything thanks to its properties as well as its processing abilities. And this has led to what we are today. That's a factory. We are manufacturing at 3 shifts. We have agreements with distributors to put it all over Europe, and the main applications are walls and ceilings. But that's That's all right for I said that's what we have for a 500 cubic meters factory. That's what we are running right now, but that's nothing in the wood market. The wood-based panel market in Europe is roughly 70 million cubic meters a year. So in order to target it, you need to have huge production capabilities, and this is where our business model comes in. That we think it's what makes the most sense from a sustainability point of view. As we have developed the production technology, so not just the process, the chemicals and enzymes, but also part of the equipment, we own all the intellectual property of it. And we have developed it in a way that this technology can be implemented in a small to mid scale nearby where the waste is generated. So instead of looking for a huge economy of scale where we just put ourselves beside the thing that travels the worst, normally the raw material, and we make a macro factory there and achieve lower cost through having let's say a very large manufacturing unit, we have already the benefit of working with waste as raw material. And what we really targeted was like, okay, how can we really make this the most efficient possible? And the first alarm that came in was that we need to avoid transport, because even though transport from a financial point of view tends to be really cheap, from an environmental point of view, it represents 1/3 of the global emissions. So it's clearly something we need to work on. And so we designed the technology in a way that it really can be implemented and be competitive in a low to mid scale. Our idea is to have what you see on the right image, a distributed network of mid-size industrial units that manufacture a product based on a local waste and for the local market. And to do that, this is our plan. So currently we're actually investing in the factory to multiply by 7 its capacity, but we're also designing what we consider to be let's say that the modular unit, that it has to have a 20,000 cubic meter nominal capacity. This number is based on 2 things. One is how much sludge normal paper mill generates, but also second thing is on the market size based on the distributors we work with. That's how we size the factory, but also in order to be competitive at a lower scale, the next parameters are the key. First of all, our technology, we came up with let's say a clever but simple technology that has a very fast construction time. So we can build one of our factories in 12 months at a capex rate, considering the low scale, very similar to much larger scale products. So which makes for the one who makes the investment, reduces a lot the risk. Factory itself is very good. We achieve a break even at low capacity of the factory, which gives it the flexibility to adapt its production to the market. And it's obviously a fully automated process. This is our roadmap to the market. And our idea is that by next year, we will build this first 20,000 cubic meters factory. And afterwards, once we have the network, what we'll have is a central unit that, aside from managing the sales and innovation, we will also share all the data from the different factories so they can learn from each other. And as they will be modular and replicated, any improvement found in one can easily be implemented in the other. And well, that's how we envision, let's say, a sustainable industrial expansion from our side. From a product point of view, that's what we are working on. We have a commitment to have 100% Cradle to Cradle certified portfolio of products. We are currently about to launch a Class B, which will allow us to have a bigger marketing in construction, as well as other requirements made by the building and furniture industry. And just to finish, this is who we are. Just to mention that we had great support from the European Union back in 2018 that really helped us develop properly both the production technology as well as the product and the required certificates.
Thank you, Paul. Unfortunately, I have to stop you.
Sure.
It was very interesting. I will be very short in my comment. I saw that the factory plan is very important for your business model. And I think was very brave, I don't know how to say, to plan the Barcelona plant full green. So it's not something we see every day. Very good.
Well, we have to be, I mean, it costs us more in terms of money, but in terms of everything else, it's who we are. I mean, our name says it all, and it's how we plan on keep on growing.
Thanks so much for being here.
Thank you.
So from